All right, so this is the second half of our rate and speed review. Textbook page 152. Okay, so number 5, the question was, so you have 3 pictures of trapezoids. And it says Al draws a trapezoid and uses a copier to reduce and enlarge it. And letter A says, find the missing numbers. Okay, so the missing numbers that you have in your book are on the original. So if we look at that first picture, the enlarged version, which is the first trapezoid that you guys have, change colors here. Right here, all of the sides are filled in for you. So you needed to look at the relationship between that trapezoid and then the next one, which was the original, and then find the missing values. So who's got a value for that top edge? Finn, what is it? It would be 2 centimeters. How did you figure that out? Oops, I need my note.
Bottom said 45 centimeters.
Yeah, nice job. So you could tell that the relationship was just enlarged had been multiplied by 5. So it was like 5 times bigger. All right, so Finn, why don't you go ahead and give me the rest of the values for those sides? This one, yeah, here, do this one.
That's 4.
Okay.
Other side is 5 centimeters.
Nice job. Okay, so we have 2 centimeters, 4 centimeters, and 5 centimeters. Okay, how about letter B? It says find the value of A, B, and C. Oh, my pen is like, there's like a lag and it drives me crazy because I can't see what I'm writing. Okay, so looking at that last picture, which was reduced, what was the value of letter A? What was the value of letter A? And these are the 2 key values you're going to look at right here between the original and the reduced. Alda, what do you have for letter A? Okay, good. So you divided it by 2, right? Okay, so you've got 1 centimeter. All right, so A is 1. What is B, Mateo?
B is 2.
Yes, good job. How about C, Elin? You said 3 centimeters? What is it? What's letter C? Yeah. 2.5 centimeters. Good job. Okay, so it's just exactly half of the original. All right, letter C said, find the perimeter of the smallest trapezoid. Okay, so we've got 1 plus 2 plus 2.5 plus 2.5. So remember, perimeter is all the way around. What did you get for that, Annie? Nice job. Whoa, hold on.
Wait, you don't need that. You don't need that.
Yes, right, because it's it's the distance measurement, so it's around, so it's just centimeters. Okay, number 6. The late charges for the rental of a DVD are $3 for the first 4 days and $1 per day subsequently. So what that means, guys, is that for the first 4 days, you're just going to be charged $3. Okay, so it's not $3 per day. It's just $3 for 4 days. Okay, and then it's $1 every day after that. I don't even know do you guys even know what renting a DVD is? You remember Redbox from a long time ago? Okay. All right, so 6A, Barlow was late by a week. Find the amount he paid. How much would he have paid if he was late by a week? Kendall? Good job. $6. Okay, letter B. Crystal was late by more than $4. I'm sorry, by more than 4 days and paid X dollars. Find an expression for the number of days she was late in returning the DVD. What do you guys say for that? Go ahead.
You said 4 plus B.
Ooh, 4 plus B. Okay.
I have my own variable because I know.
Well, let's see. She was late by more than 4 days. How does she, if she is, let's say 5 days late, right? Where the number of days equals X. Okay. So let's say she's 5 days late. How much is she gonna pay you guys? How much will she pay? $4, right? Let's say she's 6 days late. How much is she gonna pay, guys? If she's 6 days late? No, you're right. $5. Okay, so if she's 5 days late, she pays $4, right? If she's 6 days late, she pays $5. She's 7 days late, how much does she pay? Okay, can you guys see a relationship yet? Yeah. Ooh, except that it asks us to do X dollars and not X days, doesn't it? Okay, well, you're seeing the relationship between days. Charlie, do you have an idea? Yeah, why don't you just tell us how you did it? Because I was thinking days equals X and I read it incorrectly. I'm sorry, because dollars needs to equal X. So yeah, go ahead and tell us what you did. Hang on. Yeah. Okay, great job. So you said 4 plus X minus 3. You said 4 for the 4 days, right? Because it was more than 4 days, plus X would be the dollar, and then minus 3 for the minus $3. Now, can we simplify that? 4 plus X minus 3? What terms can we combine in that expression? Well, we can combine the numbers, the X and the 3. So let's rewrite this. 4 minus 3. Let's put the X in front. So X plus 4, right? That's a positive 4 minus 3. So the 4 and 3 are like terms. Those are both just numbers, both just integers. So if we combine those, what does our final expression become, you guys? X what? Plus what? X plus 1, good. And remember, we're going to put a dollar sign in parentheses around that. Good, X plus 1. Nice beginning there, Charlie. Good job. Okay, Dave is late by 10 days. Find the amount he paid. I meant to tell you to stop saying to not do in 2 different ways, because that didn't make any sense. So how much did Dave pay for being 10 days late? Kendall. Okay, great job. Wait a second, $9, is that right? Okay, for some reason I don't have my answer up there. Yeah, 3 for the first 4 days. No, he was late 10 days. 7, 8. Oh yeah, okay, good. All right, so did anybody get number 7? Or think they got number 7? All right, well, let's do 7A. Sam and Terry ran on the treadmill. Sam started 10 minutes before Terry. Terry finished 5 minutes before Sam. They both ran the same distance. When Terry finished, Sam had completed 4/5 of the journey and still had a half of a mile more to go. Whose speed was faster, Annie? Yeah, that one's not too hard, is it? Terry's speed was faster. Okay. All right, so letter B says find Sam's speed. How do we find Sam's speed? Distance over time. Okay, do we know the distance?
Yeah.
Well, yes and no. All right, you guys, there's a lot of stuff going on over that side of the room. You guys need to focus here. So the word problem is worded in a way that we can figure out the distance. Go ahead, Alex, explain.
Half mile, you ran it half mile. So that means you ran half an hour, 5 minutes, so 10 minutes for a mile.
Oh, I like the way you did it. That was different than the way I did it. Okay, so you noticed that he would have taken 10 minutes to run the mile. Okay, so let's see. Let me start at the beginning. You said he takes 5 minutes to run half of a mile. So in 10 minutes, he would run a mile. Okay. So is that his speed?
Yes.
Not yet, right? Okay, because what speed is always distance over a unit, like one unit of time, right? So we need to get that time to 1. So now what? Yeah, let's divide by 10. So in 1 minute, Sam would have run 1/10 of a mile. So Sam's speed is 1/10 of a mile per minute. Okay, we could convert that to miles per hour if we wanted to, right? We could multiply, if we wanted to do that, we would do times 60 minutes per hour, and that would give us 6 miles per hour. It doesn't really ask us to do that, so we wouldn't have to do that. All right, how about Terry's speed? How are we gonna find Terry's speed? Did you get that?
I was still working on it.
Okay.
I have
Anybody have an idea? So it says that, so if you look at the diagram up here, Terry started 10 minutes after and finished 5 minutes before. So you guys, eyes up here, please. Just, okay. I have broken up this bar model into 5 sections because it said that Sam had completed 4/5 of the journey. All right. So his fifth, and he still had a half a mile to go. So that told us that 1 unit equaled a half of a mile. How many units did Terry run? Yeah, what's that? Well, did he run 5 minutes? Charlie? He ran 2 minutes?
No.
He ran 2 units, right? So yeah, if you look at this, the units are, they're representative of 2 things. Each unit represents 5 minutes, but also a half of a mile, right? At least for Sam. Okay. Yeah, at least for Sam. So, but we can use the time here to find a speed for Terry. Okay. Oh, no, we can use it. We can use the time and the distance to find the speed for Terry. All right, so for letter C, Terry, what's the mileage that Terry ran, you guys? Yeah. Charlie? 2.5 miles?
Yes, they're in.
Oh, so he did run 2.5 miles. Okay, sorry. So the total distance equals 2.5 miles. Yeah, you're right. So, okay, so with speed, so he runs 10 minutes. And he takes 2.5. I cannot, with the pen and the delay, it's so tricky right now, you guys. Okay, he ran 2.5 miles. So let's just do miles per hour so we can multiply instead of dividing that decimal. So in 60 minutes, he would have run 2.5 times 6. Okay, so what's that, guys? What's 2 times 6?
12.
Okay. All right, so 2 times 6 is 12, and then we have another 0.5 times 6. Yeah. 15, good. So in 60 minutes, he will have run 15 miles. So his speed is 15 miles per hour. There it is. Okay. Okay, awesome. Okay, so keep your papers out, guys. So just a reminder, as I'm looking around, I'm seeing that a lot of people are not taking notes while we're going through this. When you're solving speed problems. Okay. All right, number 1, raise your hand when you have the answer. There are X boys and Y girls in a class. Each boy donates $3 and each boy donates $5 to a cause. How much did they donate in total? Answer, express the answer in terms of X and Y. Go ahead and write it before you raise your hand. And raise your hand when you have it. Okay. All right, Bastion, what did I write? Yes, it is, but you're forgetting something. Dollars. Okay, remember, here's how we write that. 3x plus 5y. Okay. All right, let's move on. Tyler, you're not. Oh, okay. Right, we need to be writing down exactly what you see up here. All right, next one. Solve 3x plus 4y plus z when x equals 2. Ooh, this is tricky. Y equals y plus 2 and z equals y plus 3. Okay. So before you go on, make sure you write a value for y and z to substitute in. This is a substitution problem, okay? So we're gonna have more than one line of work. Okay, make sure you guys budget your space on the back of that paper. Z. Not quite, okay. Kala. No. Go ahead. Nope. Let's start with the second line of work here before we give an answer, okay? So we've got 3 times 2 plus, ooh, what did y equal? It's x plus 2. Okay, 4. What did z equal, which was, yep, okay, so we've got 4 times 4 plus 7. All right, what's my final answer? What is it?
41.
No. Nora. No. Maddie. Okay. So we have 6 plus 16 plus 7. 6 plus 16 is 22 plus 7 equals 29. Okay, you guys, it doesn't hurt to write extra lines of work. It'll help you. All right, write 4 3/5 as a decimal. Raise your hand when you have it. Isaac Ring. 4.6, nice job. Any questions on how to do that? Okay, good. All right, let's do numbers 4 and 5. Do both, go ahead and do both of them, guys. All right, number 4. Number 4, a fraction in its simplest form. Finn. No, mixed number. It's a, yeah. Good. If it's in its simplest form, then it would be a mixed number. All right, solve 2 2/5 plus divided by 2/5. All right, Maddie. Great, tell me how to do it. Okay, so 2 2/5 times 5 halves. Okay, we need to change that 2 2/5 to an improper fraction. So we have 12/5 times 5 halves. And the answer is 6. Okay. Last round, speed round. Be careful on this one, you guys. Okay, Austin, what is it?
5 to 15.
Nice. Tell us why. Why 5 to 13? Hold on, you guys.
There's 10 red beans
Okay.
in the container.
stop, hold on. Class, put your hands together. And listen to this explanation, please. Keep going.
So then I got 10 to 6, which simplifies to 5.
Okay, so you got 10 to 26 and you simplified 5 to 13. Nice job. All right, so test tomorrow. Your